Alright, the next bit of code we're going to write is going to be the most difficult part of this project, and that's where we're going to actually place the 3D object into our app inside of the camera. And so as you can see on the right hand side here, I've got my iPhone streaming just in case we need some video. First thing we need to do is install another package for our app. So I'm going to open up Expo XDE and go to a terminal in my project directory. The package we want to install is npm install -S, and we want to install Expo asset utils. So expo-asset.utils. And we'll let that install. I wanted to mention that some of the code we're going to write for placing the Google Poly objects into our screen I actually got from this Google VR GitHub repository. They've got some examples with HTML pages for placing those objects in there, and so I used a lot of their code as an example. We're also going to need a couple supplementary files from Three.js. Since we're loading Obj files, we need the Obj Loader, and we'll also need the Mtl Loader. So if we come down at the bottom of this page on Three.js's website and click source, we can get the Obj Loader source, and we can click raw and just copy this all and put this into our project. So I'm going to run over here and let's figure out where we want to put it. I think we'll make a new folder and we'll call it util. And let's make a file called objloader.js, paste that in there. And just to verify, we've got some contact information if we need to go back and look that up. Alright, back on Three.js's website, we also need the Mtl Loader. So if we come down to the bottom, we can also find the code for the Mtl Loader right here. And we'll click raw, copy that, and let's make another file called mtl-loader.js. And once again, paste the code in there. Alright, now let's go back to our Google Poly.js file. And so far this class has only been for working with the API, but I think we can also put a function in here for generating the 3D object model that we need to use with Three.js. So at the top of the file, let's import a few libraries. We want to import Expo 3 from Expo 3. We want to import asset utils from Expo asset utils, which hopefully we just installed. We can check that. Looks like it installed successfully. We want to import star as 3 from 3. And we also want to pull in our Obj Loader and the Mtl Loader that we just saved. So we can do that by using require and giving it the path. So we'll say ... to go up one level, and then it was in our util, Obj Loader, and the same thing for Mtl Loader. Oops. Okay, so that should give us access to all the functions that we're going to need when we're creating the function to generate the 3D model. So let's come down here into our class, and let's just make a static function. And we'll call it get3model. In this case, 3 stands for Three.js. And what we're going to get is, as a parameter, is an object data object. And this is the same kind of object that we'll receive from the Google Poly API. And we also want to have 2 callback functions. Let's have a success function and a failure function. So if anything goes wrong, we'll call the failure function. If everything works properly, we will return the 3D model inside of the success function. So a couple things to do is, just to make sure you don't crash, is I always like to check if the functions that were passed in were actually passed in. So if we check if not failure, then we'll reassign failure to just be some function. That way if we try to call failure later and it doesn't exist, it won't crash. Let's do the same thing for success. And let's also say if they don't pass in object data, so if not object data, then we'll actually call the failure function with some error message that says object data is null or something like that, and return from the function so we don't do anything else. All right, the rest of the code I'm going to dictate as I type it, but like I said, most of it just came from the Google VR code right here. And you can study it some more if you want. A lot of it has to do with the format that the Google Poly API returns data into. So you can follow along if you want, or you can fast forward this part if you're not interested. So this section of code, we're going to search for a format. We'll create a variable called format, and it will look into object data.format. We'll use the find function to look for a format where, let's see, put some brackets here. We only want formats that are type OBJ. And hopefully our API filtered that, but just to be safe, we can check for it here. And if we were unable to find one, then we will call our failure function again, and we'll say no format found. And return from the function so we don't do anything else. Now we need to search for a resource. So let's put a little comment here that says search for a resource. And we'll create a variable called object, which is equal to format.root. We'll create another variable called mtl, which is equal to format.resources.find, and we're going to look for a mtl resource. So let's grab all the resources, and we will return resource.url.ends with mtl. So what this is doing is it's searching inside of the resources for a single resource that ends with mtl. I also want to look for textures, so let's do the same exact thing. Format.resources.find resource. And our textures will hopefully be PNG files, so we'll return resource.url.ends with PNG. And we also want to grab the file path, so we'll say var path equals obj, which is the same as format.root. .url.slice, and what this does is this takes out the relative path and gives us our path data. So all this code has done is basically looked through the object data structure and pull out some files that we are going to need when we use the Three.js APIs. So what we're going to do now is load the MTL file. And to do that, we need to create a loader, which is an instance of a 3.mtl loader. And then we'll set cross origin to true, because we're pulling these files from the Google Poly API. And let's set the texture path to the path that we found up here. Finally, we'll do loader.load, and we'll give it the URL of the material that we found. And that gives us a callback function with the materials as a parameter. So once that's loaded, now we want to load the OBJ file. So let's put a comment, load the OBJ. And we can reinitialize our loader to be an Obj Loader. I actually don't think the var is necessary. So now we're changing our loader to be an Obj Loader, and we're going to load the OBJ. So we'll say loader.set materials, and we'll give it the materials that we were given. And then we'll call loader.load obj.url. And let's make this an async function, which takes an object, or gives us an object parameter. All right, so at this point we've got our material loaded and our object loaded. What I've noticed in using some of the APIs is that textures are sometimes available and sometimes they aren't. So we're going to do a little check if there is a texture. So we'll say if there is a texture, then we want to apply it. Let's put an if statement here. If text does not equal undefined, then we want to say var text URI equals await, and this is where our asset utils will come in handy. Asset utils.uri async text.uri. Oh, I'm sorry, that's text.url. And then we'll create another variable called texture, which is going to be a new 3.mesh basic material. And you give it this syntax with a map variable, and then we can await expo 3.load async the text URI that we just got right there. And should be no semicolon here. And then we need to use this object.traverse method, which takes the child. And if we found a child that is an instance of a 3.mesh, then we will say child.material equals the texture. Okay, so just to recap, and like I said, I didn't really write most of this code. I took a lot of it from this repository. What we've done here is pulled out some data that we needed to use out of the object data structure. And here we use the Three.js Mtl Loader and Obj Loader to load the materials and the objects and potentially load a texture if there was one. And at this point we should now have our object initialized and ready to go. So down here we will say return the object, and we'll call our success function with the actual object that we created. So now we should be able to test this out. We'll save it, and let's go back into our home screen. And the way we'll test it out is using our turkey object that we created a second ago. So we need to figure out where we want to actually load the turkey object. And why don't we create a button, and when we click the button we'll try to put a turkey in the screen. So let's wrap this around a view with a flex 1. And down here we'll put our button title equals add turkey, and then on press will be this dot on add turkey press. And this is just a test button to make sure everything's working. We're going to delete it later. Let's save it and make sure that we can see our button. And while we do that, we will create the on add turkey press function. Okay, so here's our button down here. So that should be good to go. Now the next thing we want to do is call our API function that we just created, which is called get3model. So I'll copy that, and let's call Google Poly dot get3model, because remember it's a static function, and it takes the turkey object or any kind of Google Poly object as the first argument. The next one is the success function, which is going to give us the object. So we'll put a blank there. And the next argument is the error function, which will give us an error message, and we can just do a console.log error to help us figure out if there are any errors. Now inside of this function, we've been given the object, and what we need to do is actually add it to the screen. So that's relatively easy to do. All you need to do is say this.scene.add object. And since we're accessing this inside of a function, we'll need to bind the function to this context. So we just put .bind here and give it this. And now we have access to this inside of that function. Another thing that's a good idea to do is use this utility function inside of expo3.utils called scale longest side to size, and we give it the object and you give it some sort of scaling factor. I don't know exactly what it means, but I just experiment and I found out that 0.75 works pretty well for these Google Poly objects. So what this is going to do is resize it a little bit so it's not huge, and then we add it to our scene. So let's save this and see if we can get that working. And actually, before we try it, let's do some console.logs just to give us a status. So object loaded, this will tell us if the object was actually loaded. And I think another thing we'll want to do is set the object.position.z equal to, let's say, -3, so it'll be a little bit in front of the camera rather than directly on top of the camera, which is where it would load by default. So we'll save it again and let it reload. Okay, so I'm holding my phone up. As you can see, the camera's moving. Let me bring this to the foreground. And I'm going to click the Add Turkey button. And as you can see, it crashed. So we need to debug what this issue is. It says loader.setMaterialOptions is not a function. That was right here. Let me double check the code reference that I was looking at. Okay, it should actually be set materials. I'm not sure why I typed that. So let's save it and load it again. Hopefully it'll work this time. Okay, I've got my phone up, and by the way, here's the code I was looking at. And I'm going to click Add Turkey. And there you have it. There's a turkey, but the weird thing is it's completely black. And we'll figure out why in just a second, but one thing to note is I can move my camera around and the turkey stays in place. It's not perfect. If I move close to it, it seems like it gets a little bit further away. I can't go behind the wall, obviously, but for the most part, it stays where it was placed, which is at Z -3 and pretty much level with the camera. So I'll put my phone down and let's do a couple of things. Why don't we rotate the turkey a little bit so that we can see the front and back of it. And then we'll try to figure out why it's completely black and why it doesn't look like the thumbnail that we showed earlier. So one way of rotating the object, if we go back to the home screen, is every time onRender gets called, which is right here, this is every time the scene updates, we can adjust some of the position of the object just a little bit. So I'll delete this console.log and I'll create a member variable called this.turkey, which we'll assign to the object. And now I have access to a member variable called this.turkey anywhere within this class, including the onRender method. So every time the scene updates, we can adjust the rotation of the object just a little bit to make it spin around. So we can say this.turkey.rotation. This has an X, Y, or Z component. You can adjust some of them or all of them if you want. Let's set the X rotation to be about, let's say 2 times the delta more than it was before. And let's also adjust the Y rotation to be 1.5 times the delta. And I'm not sure exactly what that'll look like, but it should rotate a little bit, and obviously you can make it rotate faster with higher numbers or slower with smaller numbers. So we'll save that and let it load and make sure that that works. Okay, we've got another error that says undefined is not an object. I think that's because it's possible for the render method to get called before we've finished loading the turkey. In fact, we didn't even press the button. So let's put a if statement in here. If this.turkey exists, then we'll try to rotate it. So I'll save that and reload. Okay, so it's finished loading. I'll hold my phone up and click the Add Turkey button. And as you can see, there's our turkey. It's still all black, but it's rotating now. And so let's figure out why we don't see any color. The reason's actually because you need to put some lights into your scene. So if we come up here to where our context gets created, remember we created a renderer, a scene, and a camera. Let's also create some lighting and add that lighting to our object. Now, there are different types of lighting that Three.js provides, and you can find information about that on their website. We're just going to add some ambient lighting because I think that's the easiest to add. So let's type a comment that says initialize lighting. And we're going to create a variable called ambient light, which is equal to new 3.ambient light. And you can give it a color, let's say AA. And then all you have to do is this.scene.add ambient light. So this should add some light into our scene, which should then allow us to see some colors on our turkey. Here we go. Let me hold it up and add the turkey. And I accidentally pressed it twice, so we've got 2 turkeys. But you can see there's some color there. Why don't I just refresh it?